nice facility, nice day to be inside. Yeah, but I'd like to also say thanks to Experis. I always pronounce it incorrectly, but we are familiar with you guys in Sioux Falls as well. So appreciate it. This is a really, really nice facility. I don't know, I'd be sleeping in one of those couches if I worked here. But let's get started. So as Matt said, I am Joe Ratzloff. I'm the Director of Software Engineering up in Sioux Falls at Meta Payment Systems. I've been around software engineering and engineering in general for quite some time. Mostly in software, I guess, for about 20 years, in a variety of different industries. And so I've had the dubious distinction of working a lot of places, doing a lot of different business processes within different companies. But it seems like I always kind of found my way into this integration vein a little bit, either making machines work together when I was an engineer or making software platforms work together. So today, what I'm going to talk about is a little bit of that, about making systems work together, really with the topic of integration, different integration options, how to make those systems work together. We all know a variety of ways. We'll focus mostly on messaging, and as part of that, I will demonstrate a tool I've used for those kind of things, which is N-Service Bus. We'll talk about a couple different architectural styles around messaging, the bus and broker style, and do some demonstrations, try to talk about some of the features that I won't get to, and some of the bad things, or some of the hard stuff. It's like somebody told me about Java right a long time ago, right? Make some hard things easy, make some easy things hard, right? These patterns aren't different that way. Now, a little poll first. How many of you guys are doing messaging right now? All right. Wow, quite a bit of you. Oh, that's great. As I present, I don't mind being interrupted, right? I kind of like it to be more of a conversational thing. I'm going to have a handful of slides kind of on the topic, and we'll get into some demos. But just raise your hand if you have a question at any time. All right. So this integration thing, right? It's about making systems work together, and mostly around making processes that span multiple systems work together, right? And when you dig into N-Service Bus in particular, the way that was conceived of, it's really about making services work together in the service-oriented architectural style that the founder of N-Service Bus, this gentleman, Udi Dahan, came up with. And that's a little bit different than what I would say is the traditional SOA description. So, through our demos, we'll get into that a little bit too. If you've done a lot of messaging, maybe you guys have seen this book. This is the one that I got quite some time ago. And if you're going to get into messaging, there's a lot of patterns. Just like the Gang of Four patterns, there's even more when it comes to the fun topic of messaging. And there's a lot of products out there to help you with this kind of stuff. BizTalk, ActiveMQ, TIBCO, CBeyond, Vitria. There's a lot of old ones too that go back to really when this technology used to be called EAI, right? As this Enterprise Application Integration is kind of an old term I remember from my Java days. So throughout the demonstrations here, I'm going to kind of use this sales example, where we have kind of this sales system that is predominantly about taking orders. We've got this shipping system that has to schedule for their shipment, and then once shipped, we got to bill the customer, for that order. And we'll talk a little bit about the various ways that can be accomplished. All right, any questions so far, guys? All right. I'm going to kind of rapidly go through some of these because I don't want to starve out demo time. But like I said, if you want me to slow down and talk about any part in particular, just tell me. So, in that book, they even have these little diagrams, right? But they talk about some basic options for integration, right? We can always exchange files, right? Anybody that has not done that, right? That's pretty ubiquitous. Sharing a database, maybe we have a staging tables, stuff like that. RPC calls, right? DCOM, Corba, RMI, web services, NetDDE, if you're really old like me. Maybe not. That's right. Messaging is of course our topic tonight. So let's talk about, how do we distinguish between, quality indicators on these different things, right? And it's always kind of a balancing act, right? Some are easier, but they have different pitfalls. Some are harder, but maybe they're more robust. I kind of threw this slide together because, to me, it's important to have loose coupling, right? As I've done a lot of this kind of stuff, I don't like it when systems are really tightly coupled. They have a lot of mutual dependencies, maybe dependencies in code, maybe dependencies in time, right? I can't do my job till you're done with yours, and we kind of got to take turns, these kind of things. Concurrency issues is kind of another form of coupling, right? So we don't dig those things, right? And the transactional support is another big one, right? I have to pass that acid test, right? What's that stand for again, right? Atomic, consistent, isolated, durable, right? So I don't want to get a bunch of duplicates, and I don't want to get a lot of false positives. I want to keep consistency in both systems as a result of this integration, okay? And it should be developer friendly, right? I mean, it can't be impossible to do, and maybe it's even cross-platform, right? And that way it makes these systems not be tied to the same technology stack, okay? So we'll look through those real quick and talk about some of them. Like we said, exchanging files, man, who doesn't ever do that, right? It's maybe if you're real lucky, you even exchange spreadsheets, right? 'Cause that is the universal file spec, right? Everybody can do it. I mean, you can even, you can do it in any language, right? Well, what are some of the cons? One of the pros, though, really is it is loosely coupled, right? If I dump a file out and I hand it to you, I've got no dependency, right? I'm free and clear. And I got a good contract if I did that file spec nicely. If I did a big COBOL copybook, it might be a little harder. But, maybe you got a good spec. But you are kind of temporally coupled, right? I mean, I do my stuff, I give you a file, then you do your stuff. It's not real rapid. It tends to happen batchy and periodically. And the file systems I've been around anyway are not transactionally solid. It's real easy to maybe make a half a file. My process of bends, it's not like it rolls back and deletes that half file. So it's possible for me to pick up and send you the same file twice, or part of it in one thing, and then maybe you got some stuff I didn't want you to get, or worse, miss some things, right? So let's try shared database. Right? That's also easy to do. At one point in my life, I was dealing with Oracle CRM, right? Anybody do Oracle ERP here, right? Yeah, right. Chris does. So they used to have what they called their API, right? And there's an old VB6 order. I'm like, awesome, this is going to be easy. Well, what they meant was we have a bunch of tables you can jam stuff into, and from there we will read them. And then, if you want to insert some contacts, go to this table and jam them in there, and we'll suck them out of there, right? So that's pretty easy, and it's also transactional, right? In almost any language, you can make a good connection, JDBC, ODBC, you name it, right, to a table. I can get my stuff in, and you can transactionally connect and get your stuff out, right? And the downsides then are they are tightly coupled, right? If I'm reading to that database and you're trying, or if I'm writing to it and you're trying to read from it, we have transactional integrity, but we also probably got a little blocking going on, right? If we're both hitting that thing really hard, and maybe I make a view instead, right? You see this a lot in SQL. Well, hey, I want you to interact. I'll just make a view, and then you interact with that. But what it does is it does bind your two systems within some transactional kind of wrestling match. And eventually, right, so in our little example, if I'm sales and I want to register orders with the shipping system, right, I could jam them in a table over there in shipping as I do them, or dump them in a table in my system and let them kind of pluck them out of there, right? Or I could give them a view, right? Hey, shipping, just come and bang this view all day long, fishing for orders. But, who's done that before? I sure have, right? What do they say if suddenly the sales guys say, well, holy balls, you're really wailing on me here. Stop blocking all my stuff with your query. So what's the one word you can put in that select statement to stop that? No lock. Is that a great idea?
No.
Right. It's that transactional thing, right? It's that false positive. I stick that order in that table, you come and no lock your query and pluck it out of there, and then I roll back. thank you for shipping my order I never placed, right? I wish that happened more, right? Like when I'm placing it. So if any of you guys work at like Apple or Amazon, something like that, you can keep doing that. That's okay. All right, any questions on that? That's pretty self-explanatory, right? So we got RPC. Also, nowadays ubiquitous, right? Believe it or not, this stuff used to be a pain in the butt, right? Before web services, you know, it was a pain. If you've ever used like Microsoft's host integration server or something like that, or perhaps eaten glass shards in your life, it would be similar experiences, I would say. But you know, nowadays you get a WSDL. I got a nice contract, right? So you know that's pretty cool, right? And it's really kind of in the wake of DCOM became Microsoft's go-to integration standard. They virtually talk about nothing else. At least when you go to like a .NET training class, right? You know, be it MVC, be it anything, right? You're either going to go with entity framework straight to a database or a web service, right? They train you on almost nothing else. And because it's super easy, right? Now the transactional story is not great, right? There's this WS Atomic. Has anybody ever seen anybody implement a service or come across one? Really?
Once.
Wow.
It was a nightmare because half the build supported.
And so you always say it's kind of like Bigfoot, right? It's often talked about, but never
They
seen.
tried to use it because one half system, what's WS Atomic?
Yeah, right. Well, and some guys say if you support it, I'm not going to choose you as a partner because it's such a horrible idea to allow, you know, random dude over the internet to enlist transactionally, right? If I'm like an authorization gateway, right? We're in Omaha, FDR runs all these credit card auths and stuff like that. What if I did that with every merchant terminal out there and held up a transaction? Yeah, that wouldn't go so great, right? Because, you know, again, it's another one of those features, right? It's kind of the blocking nature of RPC. It's like a phone switch, right? I used to do phone switches. As long as I'm in that phone system, that port is tied up. And if that back end is out there clocking away, I'm going to see those ports and those phone ports just get used up, right? And they will block until however long that back end takes, right? So that leaves messaging, right? In that, I think it's pronounced Hoppy in that book. You know, he kind of says this asynchronous messaging is kind of a reaction to all those bad things. It's this sending a message does not require both systems to be up. It's this fire and forget kind of thing, right? I publish a message or I send it off. It goes into some messaging system. I hang up the phone and I care not what the result is, right? I don't know. But at some point, maybe later in the future, I get a response back, right? So now that phone system, I used to joke when I worked in the credit card industry and I had a lot of IVRs, because before the smartphone, people actually called and got their account balance that way. It was the weirdest thing. But you could watch that thing and you'd see these ports fill up at noon, you know, and people were calling to check their balance. And, you know, we'd have to buy more machines because as one machine got full, right, we'd have to get more. And I used to joke all the time, right, I should have patented it, right? I told my friends, I said, you know, the smart thing to do would be go asynchronous in an IVR. It says, please enter your, you know, 16-digit account number and the last 4 of your social, and then you just immediately click. Thank you, hang up the phone. Right? Free up the ports, and then maybe a minute or two later you call them back and say, your current balance is. Right? So we used to joke about how that would help our scalability, but crazy enough, they kind of do that now, don't they? Right? Who says text BAL to whatever? Right? It happens all the time. Right? The other example I saw in the news was Hurricane Sandy. Right? They're all worried about the cell towers during the storm. Right? Everybody's going to saturate them. So what do they tell people to do? Text, right? Because it's store and forward, right? Eventually, your message will get through. It's secured in the messaging infrastructure. When it can get it through the pipeline, it'll do it. And that's what I mean by messaging here, right? And so less coupling. These messages are really XML as a contract in messaging. All right? Any questions, guys? All right. A couple major messaging patterns, right? The bus and the broker. Did you hear about? Who does BizTalk here? Anybody? Anybody? Anybody do TIBCO? You guys did messaging, some of you guys. What do you use? You're on .NET though, right? So if you're not using BizTalk, you're probably using something, ActiveMQ.
MQ series.
Message broker, MSQ.
Right. Service broker maybe in SQL, right? Yeah, so there's the broker, right? And that's kind of like, if I want to allow different systems to send messaging to each other, but I want something to really control that addressing and keep control over all of it, I pick a broker, right? It's kind of a, they call it hub and spoke, as you can see by the picture, right? So the hub knows all, tells all. And usually with systems like that, you can walk into the data center and, you know, behold my messaging box, right? This is the big iron BizTalk server with its message box is a big SQL instance, you know, at least when I used to investigate it anyway, I should say. So that's kind of the way a broker works. TIPCO, we used that in one of the banks I was at, and I understood it to be more like a broker as well. I used a really old one called Vitria. It's, I think, probably all but eradicated from the face of the earth, but that too is a broker. And then there's the bus, right? This is also about making systems work together, but in a way where you can add them in, and they're more peer-to-peer, right? It's a little bit more like Ethernet versus token ring, peer network, right? I'm dating myself every time I speak of it, but you know, it's with Ethernet. There's no, you don't walk in the data center and behold my Ethernet, right? It's a little part of every machine, right? And that's really what the bus kind of becomes like. Right? So other patterns maybe you guys have seen would be like pipes and filters. We used to do these kind of like the old filter chain where you'd publish a message and one thing would pluck it out of the system, do a little bit of work, maybe enrich some data, and then send it down the line to the next guy. And you could get a lot of stuff done by pipelining that way. But we're going to talk about the bus pattern here, right? But if you are committed to messaging, and a lot of you guys are, I would just suggest you go out and find something. Right, there's N-Service Bus, of course. You can get into BizTalk if you're on the .NET stack. These AQMP, like Rabbit, some of these are nice as well. There's a bunch of options out there. But if you want to go it alone, man, you got to think of all this stuff, right? What is a message? Where do I store it? How do I send it? How do I serialize it? How do I deserialize it? How do I encrypt it? How do I secure it? You know. Don't make your own databases, probably your own OSs either. Right? Your own security algorithms for encryption, probably a bad idea. Equally so, probably to roll your own bus. It's kind of a pain. So that leads us to the demonstration side of things, right, which talks about N-Service Bus. It does implement the bus style, as you'd imagine from its name. You got a collection of endpoints, right? That's what it talks about. So you can host these endpoints in your own process, right? They just need a call stack. So if I'm in a console app, I can host an endpoint, right? In a website and a web service. And I can also use what they provide as an N-Service Bus host, which generally runs as a Windows service, okay? But it's built on top of existing stuff. It does not take care of its own messaging. It out of the box wants to leverage MSMQ, which is the Microsoft solution that's been around as long as I've been on that stack. It also uses SQL and RavenDB for persistence when it has to store stuff. And it does logging. It's got pluggable logging out of the box. It wants to use log4net. It does register some pens with WMI. And you can just go download it. Now, it used to be open source. When I found it, I think it was like 1.8. But now I guess what you'd call it is commercial open source. The good news is it's cheap. Okay, it's like 500 bucks and per core. So in our topology of work, we only need about 4 licenses. We got a machine that does a lot of publishing, but that's not bad, right? If you're going to add a machine to publish messages, you know, and they might even change that stuff to say if you want to publish, it doesn't cost you anything. So kind of how it works is you have like a client endpoint and a server endpoint. The client, you know, publishes this message and it goes into the MSMQ stack, and MSMQ then takes it and hangs up the phone, right? So the code you wrote is moved on. MSMQ will forward it to the machine that it's addressed to, at which point it's plucked out of the queue and it fires what we call like a handler on the other end. And if it replies, it drops it all back the same way, right? It goes in the outbound queue of that machine and all the way back to the client, which is called kind of this full duplex, right? So in both cases, you know, I sent it, I hung up the phone, and a little while later it came rattling back. What am I guaranteed? I should get it back. When? You know, God willing someday, right? But you have to kind of tune yourself to that reality, right? That's that trade-off, I suppose. Right? If you're used to having that answer right away, think again, right? You have to figure out a different way, and we'll talk about that, right? So what does an endpoint need? It needs a handle to the bus, and it needs a queue. That's it. All right, we'll do a demo. Any questions? Good pizza. All right, let's see here. All right, so end service bus is really just a bunch of DLLs. Okay, there's no, you're thinking Windows workflow, you know, draw icons and chain them together. And they have a little studio plug-in, but I predate that, so I kind of do it the old-fashioned way. And even the studio that they give you really just generates code anyway, right? But you'll see the code's not real complicated. So I need a message, right? If I look at this demo message, I have it up on my screen now. It is just a POCO, basically, right? A plain old CLR object. And it does implement this magic interface, okay? iMessage. That's the end service bus dependency you see up here. Right, so there's my message. I need a queue, so I can go into the old MSMQ dealio here, and I can say new private queue, and I'll call it simple receiver. That will make him transactional for all those reasons we already talked about, right? I don't want to lose this guy. Okay, so there he is. Okay, so now in my little program, this is just a console app, right? Stick and stone stupid. This thing doesn't do anything. But I do have to instantiate the bus. So in my sub main here, right, it has this Fluent Configuration API, right, where I go configure it, and I got to go through and say, default builder. It uses IOC.
Can you just make that just a little bit bigger?
Yeah, I'm sorry.
Just maybe up to 125 or
Anybody give me a good pointer
150.
on how to do that on here?
Go down to the left corner of your code, just the code side of it.
Oh, okay, yeah. What do you think of? We tried.
110. Yeah, that's a little bit better.
Any better? Let me get this junk out of the way too. It doesn't contribute much.
Anybody else?
That's good.
It's a little bit better, easier to read now.
Yeah,
Thank you.
no, I appreciate you giving me the heads up. So, all right, so we gotta instantiate the bus, right? Because I want to talk to the bus, so I got this bus object. It uses IOC, so that's what that default builder is. It says, hey, use your default IOC container. It supports a bunch of them, but in this case, right, it kind of bootstraps itself. I tell it what transport. It only supports unicast, so that's obligatory. And some of these things are features we'll get to where I'm disabling them. But eventually, right, that bus is instantiated. I go out here and I new up, right, a simple order, which is that message class we looked at. Bus.send order message, right? Pretty simple. Let's see if the gods are smiling. All right. No big deal, right? So where did that order go? Thank you, right, yeah, kind of into the ether as far as the app's concerned. It's just gone, right? That next line of execution, there's no blocking, right? It didn't wait. So if I go out here now, I'm going to switch tools here, guys, because I got news for you. The MSMQ tool that comes with Windows is bad. Okay, well, it's adequate, but you can't see some of the glorious innards of a message.
Which tool are you using?
This is called Q Explorer by a place possibly pronounced Kogin or Kogin or something like that. It's pretty cheap, and it's just a little better. I mean, we can go look at it in both if you guys wish, but there they all are, right? There's our glorious messages. Okay. And so, how did it know to send them to the simple receiver? Let's go take a quick look, and I'll show you how. right? So we talked about peer-to-peer, right? There's no central hub, no big address manager that said, oh, you know, you configured me to send him from here to here, right? It's peer-to-peer, so as you can imagine, I have to go into his configuration. Let's go to the other. So it says in that unicast bus is configured, and it says message endpoint mappings. The endpoint simple receiver would like to have messages of type demo messages, right? But that can be a fully qualified name, right? I don't have to be so broad. I could give it a fully qualified, you know, all the way down to the strong name if I want to, or specific type. Okay, in this case, I'm saying the entire assembly demo messages needs to go to a queue called simple receiver. And so I cheated, I kind of went out, right, and made that guy in advance. If he wasn't there, it would have barked, right? It would have said, sorry, I can't publish because I don't have a queue. Okay? And so that's it, right? It did not take much for me to wire something into the bus. Just a couple DLL references. So let's go see what it takes to receive them. And so on the other end, I cheat a little bit here. I use that I reference now this end service bus host. Okay. Now that guy uses the IOC container, but they also use Top Shelf, right, which allows it for now to run as a console app. But if I put a command line and say install on the end of it, when I run it, it'll install it as a Windows service. Okay, so that makes it a heck of a lot easier to debug. Let me just run it first, and let's see what it does. Okay, because it will look just like a console app to us, but it'll bootstrap a little bit differently. Yeah, can I make that any bigger, guys? I don't know.
That's not the problem.
Will they go really fast, you mean?
No, I'm
The
colorblind.
background.
Oh, okay. Yeah, sorry, fellas. You're not missing much. The yellow things you see are it creating the queues it knows it needs, okay? So that's kind of nice. I went in and I built the one by hand. If I'm using that generic host, I don't have to, right? It'll just do it. It says, hey, I'm going to make some queues. The main one it built is it would have made that simple receiver had I not done it already. But because of some of the durability features, it makes some other queues it uses for other purposes, specifically around retrying stuff when it fails. Okay? So let's go ahead and publish some stuff now and see if it behaves a little bit different. Right? So why weren't those guys there? Right? What happened to that first handful I jammed through when I fired it up? It's supposed to be durable. Well, you probably didn't notice that there was one change I made in that. We come to that messages. And you see the attribute at the top? It said if it's been 3 minutes, you know, don't worry about it. Right? So like in that IVR example I gave you, if they publish in a bunch of get balance requests, and that system's so busy, what's the point? You know what I mean? The guy's going to hang up the phone and you'll be chunking through messages an hour later that have nobody listening for anymore. Right? All right, any questions, guys?
About 3 minutes.
It's time to live, right? So if we went and looked in CodeGen now, let's do it. That's a great idea. Let's look. So let me refresh here. Well, there we go, because it's sucking them out of there as fast as possible. So let's close that guy. Let's jam a few more out here. Refresh them again. Alright, let's go into the simple receiver. He's got 6 in there. Okay, check it out. See, time to reach queue 2.82. We refresh that guy, it'll just keep counting down. Eventually the messaging system will just pull him out of there. Right? And that's important. Okay, we'll get to that here in a second. Any other questions?
That 3 minutes, when the 3 minutes expires, will the sending system get some sort of event or notification that it is being filled?
He is out of luck, right? So that's the thing you got to contend with, right? So it's got to be something like a stop quote, right? If I sent you a bunch of messages and the service that was calling out to get that stop quote is down, You know, so I'm plucking messages out of the queue, I'm calling this web service maybe, and I've got this backlog of a jillion because I'm having a network hiccup or something like that. I can't give that guy an answer that's an hour old, can I? You know what I mean? So you gotta, you know, in some cases you just prune them out of there. Because if they go rattling back, there might not be anybody waiting. Right? So you're gonna, it doesn't also have this notion of queue priority, right? Like some of the brokers have what they call, you can go in and say you can give them on a higher ranking, right? So if I got a big stack of junk in the queue, I can put another guy and say, you're more important than everybody else, and we'll go grab him first, right? It does not do that. Yeah, but the bus does not do it that way. Okay, so we'll get into that a little bit.
It doesn't allow it even with the substructure that does? MSQ allows it.
MSkim, yes. When I used to have to do this stuff on the metal, we used to do it, right? I'd say, this guy matters, but, you know, it's a little bit to do with that SOA philosophy, right? And we'll talk about that a little bit. Let's see where did we go. So I'm gonna go pretty quick, guys, here, because I know we have about 3 more demos to go, so.
That goes up there.
Oh, do I? Okay. All right, that's not so bad, I'll slow it down. All right, so what are the dangers of storage forward? You just talked about it, right? If that target's offline, if I've got some real rapid fire deal, what if that system, you know, I can fill up the hard drive pretty quick, right? Especially these guys nowadays, they whip out a VM and they don't give it a heck of a lot of hard drive, right? So if I have a big message bodies, right? We used to do like credit bureau reports as messages, right? They can be pretty big, right? So you could fill it up pretty quick. So we talked about time to live, right? But with messaging, right, you cannot say when, you cannot say in what order, right? So if me and 50 other guys are sending those messages in, I'm just in line somewhere. Right? So you have to kind of tune your design, right? So that was what it was, kind of one-way messaging, right? In no way did I ever reply. You know, let's look at a request response, right? So this is where you oftentimes put a message-based wrapper around a service call. So let's say I need to look up a zip code, right? There's lots of jippy zip code services out there. So I'm going to do a little demo where the client requests a zip code lookup. The server pulls the message out of the queue, makes the web service call, and does a reply back to the guy that sent it. Right? So instead of one-way communication, let's take a peek at two-way. Kill that guy out. You gotta love VirtualBox though, right? You guys use that? Ever mess around or for fun? Alright. So let's take a quick peek, right? So once again, I got a client. Let's look again, I got a message. Right, here's my zip service messages. And usually what happens in this case, the messages kind of mimic method names, right? Zip lookup request yields a zip lookup response. So give me a zip code and some unique ID and I will publish back to you a zip lookup response. So we kind of can imagine what the sender looks like, right? Not much different. So if we look at the client, right? Now in this case, I think I am doing the same old deal here again, but I'm going to use the generic host in both cases now. Okay, so we get to watch that lovely bootstrapping. But one of the differences is when I have this this client endpoint, you know, and service bus is a little old Java-like, if anybody ever did Java, a lot of marker interfaces, right? You don't see a lot of attributes on classes. You do see some. But see this, I want to run at startup. That's just telling it, hey, when you bootstrap up, give me a ring first. You know, call into this method. And if I implement, see this iBus up here? Right, dependency injection is going to push me an instance of the bus, right? And I didn't have to do anything. Believe me, I'm no IOC wizard by a long shot. It just works, right? It's the kind of abstraction I adore. It just doesn't. Okay. So in this case, I say I want to run a startup, and I got a handle to the bus, right? I don't have to go through all this stuff. It just pushed it to me. And so I'm just saying, hey, gin up a GUID, right? Put a zip code in at the command line and send it. What about the reply? So I got this other guy, zip response handler, in my client. He comes in and says, I handle messages of type zip lookup response. Okay, and so now that one guy's going to send, this other guy's got to go to receive, right? So the one guy's hooked into the bus publishing, and this other guy's listening to an inbound queue for this client, waiting for this guy to come back. And I didn't have to do a lot of gymnastics because they're doing MSMQ, you know, on the metal. You can do all this stuff, right? You can peek that queue, maybe pull it, peek it. Well, that's what the bus is doing for you. But it just looks at these handlers and says, hey, I got a message, what type are you? Do I have any handlers registered for that type? Bang, right? And just lays it in there. If you have multiple. See, Matt, you're working ahead. So let's look at the server. Okay, but you know, you see the pattern now, guys, right? So what are we going to have? We're going to have an app config, right? The other app config told it where to send these zip lookups. Now, you know, what's this guy got? Not much. There's a little air handling stuff. We'll get into that a little bit later. But how does he know where to send the response? It's in the message that he received. Right? So it's self-addressed, right? It's like an envelope. Hey, I sent you this request, and so in this guy, when we go look at this this guy's handler, you'll see that he is stick and stone stupid. He doesn't do anything, right? Same old pattern. I handle message of zip request. So I found this Jiffy zip lookup thing on the internet the other day for free. The last one I found quit working, so hopefully this one still goes. New up a zip client, right? I got a web service reference to that, right? Go get this list of results and go ahead and send back an answer, right? If you get one. Okay, but see at the bottom, bus.reply. I say not where. I know not where. Okay, does that make sense, guys? So let's just run this guy once and see what he does. I'm going to cheat this time, though. I'm going to say start without debugging. We'll take our chances. Because dubiously, what do you not see in my class if you guys were doing my code review? Did I have an air handler in there at all? All right. Some of the advice in these bus technologies don't. Because we'll see what the bus does. Okay, so once again, uh-oh. Smell that. Server. All right. Well, it forgave me, apparently. Whatever transgression I committed. Okay. So, what's the zip code here? 68116. Okay, it's got a warm up. It's Omaha, Nebraska, right? I used to do a lot of postal stuff, so I know 1, 2, 3, 4, 5 is Schenectady, New York, right? And so my hometown is not this one. Okay, but you get it. It's not that delayed, right? But in that whole time, right? Dropped it in the queue, went into MSMQ, sent it over to the other queue. Is that really, really hard to read, guys?
It's better now.
Yeah, how boring is that? Sorry, fellas. I could probably change these colors, but I got a feeling when it respawns it, it's going to change it back every time, right? I don't think my brightness jump or anything does any effect on those, does it? Can you see good enough to survive? Fellas, should we go in here? All right. So once again, right, you saw it dump in here, and you can see on the bottom window, right, looking up zip code 56164. Okay, let's put a garbage one in there. All right. That's because I didn't follow my advice, did I? I did not start it without debugging. Okay, let's stop it all. And let's do it again. You know, we're going to see it right away, right? Watch. Okay, that guy was still there, right? We proved our point. He was still in that queue. I jammed that 0 out there. And so he's kind of freaking out a little bit, isn't he? But let's ignore that, right? I didn't get my response, but let's go back and do a different one. Hatfield, Minnesota. Incorrect, but close. But what happened, right? Did I ever get my reply for all zeros? I didn't. So what is it doing? Well, it's using this retry thing, right? When it gets an exception, it throws it back into the queue.
Is it going to keep retrying until its time to live expires?
Nope, it'll go for however many retries you configure. Okay, so it defaults to 5, I believe. I might have overridden it in that config you saw. But then it has, in these newer versions of NService Bus, it even has second level retry, where when it finally bottoms out of that, it'll stick it in another queue and it'll go into a slower roll. Where you can say maybe every 10 minutes or half an hour or whatever, right? So it tries to put that durability in, okay? But these are web services we're calling. What did we say about those? Looking up the zip code, no big deal. What if it's post a payment? That would kind of suck, right? Depending on the error I got. If it's a hard, cold, stone dead error, retry. But what if it's like a timeout? Did it work? Did it not work? Right, you got to be careful.
Where you got this, you actually paid 3 times.
Well, right. And so the worst scenario in all of humanity, right, is the ambiguous situation. I don't care if you're synchronous or what, right? Those kind of stink. So now some human's going to have to go sort it out, or you got to do some kind of compensating resource manager, right? Go query to see if it did go, and if it did go, then, you know, that kind of stuff. So that's all still in full force, but it's something to be aware of, right? So now if we go out and look in the queues, we're going to see a bunch more, right? Because every time I want to run one of these demos, it jams up a bunch more of these guys. So here we go, right? Zip error, sorry. Okay, this is one of the cool things about the Cogent guy, is I can come in here and say, right? This is a real you know, this works, but Lord forbid you're the poor dude that has to do this in production. And you don't want to be the auditor either. Right?
Double check grammar.
Right, so we're going to send changes to queue, but hey, that didn't fix him. Well, drag him over here. Oh, it's gone. Where'd he go?
But then is the requester going to get a reply back based upon your changed value, which is not what he asked for?
Yes, because I fixed it. I know what he really meant. You know, that's the hazard of it, right? So, but it is one of these things, right? You know, you get these payload snafus, and when you run these things in production, right? Maybe you're taking an application for a loan or something like that, and you tested it, you know, but god dang, you know, who puts a T in their damn date, right? Some people, and then it blows up. You gotta go fix it, you gotta call them up, say, what the hell are you doing with that date? Well, we agreed on string. Okay, well, you know, so it's just computing, right? I mean, these things happen, but it's just to show you, though, if you want to mutate the messages, it doesn't care. But in a production system, right, I don't know where you work, but I could never do that, right? All right, any questions on that, guys? I'm going through it pretty quick. Go ahead.
That happens after 5, and will it ever send
Yeah.
back a message saying I think failed?
Nope.
It'll just
Yeah,
assume,
you don't remember
even
this.
though it knows an address.
That's our
send back
agreement,
the text.
right? In exchange for being completely liberated,
Huh.
right?
Yeah.
You know,
It's not like that.
It's a
In way,
Holly-
it
right.
still shows up in the queue.
yeah, it's not lost, right? So
Right.
you'll see these catchphrases. You got to NService Bus, right? One of them says, you know, no simpler. Well, you know, it's pretty simple. But who's to judge, right? But it'll also say stuff like, stop losing data. Well, what do they mean? That's what they mean. It failed gloriously. But did I lose it? If I was running web services right from the web client, where would it be? buried in some damn log somewhere, probably, right? If you remember to log it, then you'd be like out there patrolling the log. Oh, gee, I got this error. Well, then what do? You're gonna go gin up one, grab some utility and brute force that service yourself. Unaudited, you know what I mean? And, you know, so it's a trade-off, right? Okay, that's a great question though. And so what you saw is it bottoming out of the retry loop. Bang, 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 right? So when it failed the first time, that's why you saw it coming back. Just drops it in the queue and bang, 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 right? It just hits it real quick. But in the first versions of NService Plus, that's all it had. It used to complain all the time. What goes down and is back up in a millisecond? Right? Nothing is the answer. But it would just drop it to that error queue, right? It tries knocking on the door and sticking in the error queue. Now it goes through this sequence of slower rolling retries, and then when those fail, it finally does still go to that error queue. Now what if we were all on the same network and I wanted to send these messages to you guys instead of me? What code do I change? Any ideas? None. Right? I just changed my addressing in the config, right? Instead of queue name in that sender, right? So it's go find that client. So how did the client know where to send the zip? Because it was configured, right? Send my messages to my server. Well, that's the queue name. That's the endpoint name. You can change all those, by the way, of course. By default, it'll pick whatever your app is called. You can override all that stuff. But I would just say my server at machine name. And if MSMQ has got rights, it's going to take it. It's going to go to the outbound queue. It's going to be that other machine. So your topology and your config and your code, it's all decoupled. Right? It's one of the benefits that you get. But deploying them can be a little harder. Right? You got to have network connectivity for MSMQ can be a little bit of a pain. Don't have to use MSMQ though. There's other transport options. Okay? Okay, another pattern. Publish, subscribe. All right, who does this? Anybody? PubSub? Nearly not existent in the world of .NET, right? Been around Java. You know, I did about a 2 or 3 year stint in Java land. It was all right. I just got to learn OO before .NET came back, right? So I left EV6, did Java, had all these tools for messaging, and then canceled project, no more Java, back to Microsoft. Well, what the hell am I going to do with all this messaging stuff, right? So in those days, we learned how to roll our own against MSMQ, right? But events were kind of part of some of those platforms. So, you know, what is an event in messaging? The receipt of a message. Right, so think of it like we were talking about that full duplex request response. Look up that zip code. The events are almost more like the observer pattern, right? If you've ever done UI code or something like that. You know, the buttons, you know, the mouse, the button's not asking the mouse, are you over me, are you over me, are you over me, are you over me now, are you not polling it, right? If you ever hooked the old Win32 API and tried to get a call every time the mouse moved, it went berserk. Because there's just a jillion events pouring out. So if you've done UI code, especially form stuff, you know, click handlers, right, on click. So this is a different paradigm, right? So publishing an event means just sending a message to a bunch of destinations, right? If I'm going to announce the arrival of something, right, you guys could all subscribe and I'd send it to you, right? Another way to think about it's a little more subtle, right? So like when I was a young engineer, dot matrix printers, anybody remember them? Remember, what was one redeeming feature of a dot matrix printer that has them still in use today? That's it. Why? Well, what happens to each copy? It goes to different departments, right? In my joint, it was the goldenrod copy went to Denise, right? The green copy went over to the guys to go procure all the junk I just sold, right? The other copy, right? Only in the age of computing is this idea that we can centralize all of it in one spot come to bear, right? Because it became possible. If in those days I would have gone to the head honchos at the King Company and said, Eureka, let's get one big centralized file cabinet and all you guys can come up here and grab it, right? They would have said, yeah, you know, bring an empty box. Right? But, right, I mean, it works. So think of it a little bit that way. Just think of that sales example. Right? Am I, as a sales system, going to say, hey, shipping system, go ship that thing, and then wait for you to come back to me, and then say, hey, billing, shipping just told me he shipped, go bill. People do it though, right? Do you do it that way? That's called a broker. Why not announce that order to both at the same time, to subscribers? Hey, order approved. Do what you know how to do. Right? You ship. When you're done, you bill. Right? That's a distributed SOA. You get the distinction? Right? Not, go to web service class, they don't teach you that. Right? In your web page, call shipping. Block. Wait. Shipping done, billing, bill. Waiting. I said bill, damn it. Right? That's kind of how it goes, right? So what does it mean to subscribe, right? We have to map message types and destinations. We saw that. Right? So if I have an endpoint and I want to subscribe, I just really got to tell that publisher where and what to deliver, right? So, so registering a handler in a subscriber is enough to signify I'm interested, right? So if I'm over in a service and I say, I am interested in order approved events, if in my config I say where to get those, it could wire me up. It could send a message over to that guy saying, hey, if you get one of these, don't forget about shipping. Don't forget about billing. They want these guys. And so that's what the bus does. So, and it's really good at it. It is unique to the Microsoft stack. You don't see that much. I've not used BizTalk extensively, but I don't know it to support PubSub. If I'm wrong, somebody just let me know. It's happened a lot of times. All right, so this is a cheesy animation. Hey, everybody, subscribe. All right, I'm going to deal you all out a card now. What do you think that does to performance, though? It's almost linearly bad, right? The more subscribers I have, the more copies I got to deal out. Okay. Another thing to remember is that I skipped a part of the zip code demo, and it's because of you, sorry. But no, you asked about multiple replies. It turns out that you can bus.reply a whole bunch of times. In another demo, I can go back to it if we have time at the end. But that zip code thing, the reason it's wrong is this particular perversion of a zip code service brings back a bunch of them. So I grew up in a town called Pipestone, Minnesota. Right? Yeah. But when I call that service, it brings back all the little surrounding towns too. Pipestone's in the list. I just have it typing the first one. So in the other class, if I switched them out, it says for each item, bus.reply, 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 bus.reply. Okay? So that's kind of cool to stream them out one by one, right? No. It's transactional, remember? It starts a transaction with that queue and does not commit it until it is done. So if I wanted that, I'd have to shut off transactionality. Right? So if I wanted to be able to stream them back piecemeal. So that's important to remember is this thing. The reason it's durable is that endpoint starts a transaction with the queue, commits it, hangs up the phone. That's how it trusts the queuing substructure. And then likewise on the way out. That's how you stop leaking data. Okay? And if on that server I wasn't calling a zip code web service, but instead was inserting a row in a database, it enlists the database in the transaction too, right? The old-fashioned way. If that blows up, the message goes where? Back into the queue, right? So I'm guaranteed some consistency, right? Sorry, I kind of forgot that aspect of it. But the PubSub stuff making sense to you guys? Should we just do a demo of that? All right. Okay, so what we're going to see here is a publisher, and he's going to look, guys, just exactly like everybody else, right? I want to run at startup. Again, it's just a crutch to get a demo on. In real life, that almost never happens, right? You're in a web app or something and you push a button and you'd say bus dot send my order into the bus, right? But in this case, I need a call stack, so it's an easy kind of way to get one. So in this case, once again, I got messages, but there's some neat stuff in here I want you to kind of notice. Okay, see I have this El Cheapo event message. What is this guy? He says, I implement my event. Well, and this guy down here called another event messages implements him too. And what is missing at the very top here? He is clean, right? There is no in-service bus reference. This is a true POCO now, right? But it's a message. I've just decided as such, right? It could have been maybe something I yanked out of a database, came out as an object already. I can use it for a message. This my event has nothing to do with in-service bus. It has to do with how you subscribe, because it turns out you can subscribe to interfaces, which is creepy, right? But there's a reason for that. So let's look at the publisher here. Okay. So it turns out that what this guy's wired up to do is to send 3 different types of messages each time I push enter. Create an interface. Well, that's weird, huh? Right? Instantiate something implementing my event. And the next one, and you see how the bus actually comes with a factory to do that. How they do it, I don't know. Some black magic somebody came up with. But that factory will build you something that has that interface. We'll see it in action. But in these other cases, I'm just newing up the actual class, right? Just the actual object. Okay? So if we go look at these subscribers now, let's see how they do what they do, right? And so what is missing though? This quick look at the app config for this guy. Where's those message mappings? Right? When I said, hey, if it's this type, it goes to this guy. I don't need that in PubSub, because when they subscribe, what are they going to tell me? Yeah, hey, it's me. I'm over here. If you got this type, don't forget me. Right? So let's see how that works. Let's go look at subscriber 1 here. So subscriber 1 has an event message handler, and lo and behold, it's real complicated. Right? I handle messages of type event message. Just exactly like we were doing in request response, right? But since he has been configured, one thing I haven't shown you guys a lot is to say, you know, I've got this config class too that I can go in here and do, right? So you saw in the console app I had to set a bunch of settings in the bus. I can go declare an interface that says I configure this endpoint, and he's coming in here and saying one thing. He's saying, hey, I am defining events as things that are in the following namespace. Right? If we go look at the publisher, he did the same thing. So that's how you tell it. Instead of implementing iMessage or in in-service bus, there are specific interfaces for iEvent and iCommand. Okay? iMessage is like the most generic form, but if you say I'm a command, I can send you. But if I try to publish you, I will get an exception, because I'm intended only for publication. In this case, we did neither, so that sender and this receiver do have to have some common knowledge, in that in his endpoint config, he too says, for messages in the namespace with the word my message, I want it to be considered an event. Okay? So again, there's a ton of demos out there on in-service bus, and there's a ton of stuff that relatively advanced for such a short night here. Okay? But what they do is then when they wake up, let's just run it. And you'll see that what these subscribers do is when they wake up, they will reflect upon their handlers and say, holy cow, I want to handle type my message. And in the config on the subscriber, it'll tell it, say, hey, where do I go get those? And so, unbeknownst to us, a message will go from the subscriber to the publisher and subscribe him to that type, and he'll remember it. He'll remember it in memory, or he'll remember it in a database if you tell him to. And so that way, if he reboots, he never forgets. Right, so when you go publish, right? So let's go look at the publisher first. You'll see what I'm talking about. Subscribing subscriber 1 on this machine to type my messages, right? Subscribing subscriber 1 to another event message. Subscribing 2 to my event, right, to the interface, okay? And so what we're going to see is one of these subscribers is subscribing to both the concrete classes. He has a handler for 2 types, right, because there's no restriction. If I put 2 handlers in there, I handle my message, I handle another message, it'll just do it. And so now if I hit enter, this is what I have late the party. But you'll see, right? So another event message. He implements the interface, so he fires on the subscriber that handles the interface. He's the concrete class, so he fires the other guy too. This is my event. He fires, well, he only fires the second guy, right? So this is what they call polymorphic message dispatch. Okay, that's a mouthful. Right? Do you get what it means? I can say, for one message, let's say I had a composite object. Right? These are real simple. But imagine my order consisted of a bunch of different pieces, each represented by an interface. I can have one guy subscribe to an interface representing a portion of its guts. Another guy take another portion, right? But the things I want you to get is that it subscribes automatically by reflecting on those types, it sends messages in the very same bus, right? So if I shut off the publisher and I reboot the subscribers, I would see 3 messages in the publisher's queue if I started the subscribers. But they're not messages like we created. They're the ones it uses to talk to each other. And if I cracked one of them open, it would be the one telling it, hey, it's me, I want this type. Right? Make sense? Sub stuff? So I kind of foreshadowed the other thing, right? So this gets to this SOA thing, right? When I walked in, somebody asked, what does SOA stand for? Service-oriented architecture. Right? Anybody here been to that advanced distributed systems design course or seen any of the Vimeo things that this VDOT puts on? Okay. So when he talks SOA, I thought I knew what it was, right? I worked at some huge banks, and that's a valid interpretation. Microsoft says service-oriented, right? Got a service for the zip code I got. It's not a web service. In his case, he talks about these services really in a different light. Okay, but in this thing, he says, talking about these events. If an event really is deemed to represent something that's already happened, they're not asking for my permission. It's just telling me something. Right? How many in a business? How many sources for a particular event, or how many services can there actually be that emanate from a particular event? In his thought process, and in that definition of SOA, there is only one. I can't have 2 endpoints putting out the same service, the same thing. What would a subscriber do? I have to send it to one endpoint, logically. There's ways to scale them out. But you get the problem? I said, well, I could get this event for Matt or Chris. How do I configure that? Right. So his definition of a service is the technical authority for a specific business capability. That means data and rules. Okay. And so really this thing's built around that. Okay. So what is a service not? It's not a function. Check his order value, get zip code. That's not a service, that's a function. The service has only data in its database, it's not a service, right? It just does CRUD, okay? But these are what he means by services, right? So sales is a service area, okay? And how can I coordinate events, right? So between services in the distributed SOA strategy, you only ever allow events. Right? You strictly forbid RPC calls. Right, so when you go to the guy's class, he'll be like, all right, how are we gonna take this order? Well, I got the order. All right, what are some rules I want? Well, I better check and see if I got inventory. So in a different example, you might have an inventory service. Well, let's make an RPC call over. No, not allowed. If you want to know the inventory levels, guess what the solution is? Subscribe to the inventory feed. And keep enough information about inventory to take care of yourself without bugging me, right? Because we want everything to be kind of clean from each other. Right, so that's kind of the philosophy that this promotes. Okay, so in this case, we would send these order accepted events to both billing, but billing is going to also subscribe to shipping, right? Because we want the order to be placed, we want it to ship, and then we want it to bill. Right? If I subscribe in this sort of an event cascade, I can accomplish that with no brokering, which means it's not me as sales saying ship, wait. Right? That's that example I was kind of talking about. So this stuff is really kind of built around that whole philosophy of event cascades, promoting business processes. Make sense? So what if the order is, what if it says, right, I'm not guaranteed. When I subscribe to shipping and I subscribe to billing, when he comes out and he says, well, what if I can't find you in my database, right? What if I'm waiting to bill, I get the shipping notification, this is wired up a little bit wrong, I think. But imagine that the names are reversed. So shipping's down there, and he gets the order billed event, or I'm sorry, the billing gets the order shipped event before he ever got the order. Well, now what? Presents messaging, right? I'm not guaranteed what order or when or if. Well, he's going to freak out, right? Or he's going to throw an exception and stick him back in the queue, and he maybe eventually get in there. But there's a better solution to that, right? That's what these sagas are for. And this is about long-running processes providing some kind of state management that allows a service to coordinate events that arrive out of order. So what if I took that event and I did some stateful thing, right? I could store it in a database that say, so I got this guy, but I'm not going to do anything until I hear about the order. I got the order, but I'm not going to do anything until I hear he shipped. And then I'll latch, and then I'll carry it out. Well, it turns out it comes with a way to do that. Okay? And there's this notion of a saga. Think of it like a Windows workflow almost. Okay? I always used to call them orchestrations because I was trained in Beeple, right? And so I was more of a broker, right? Beeple would be more that, hey, you ship, when you're done, get back to me, I'll rehydrate my state, time to bill, right? This is a little bit different. I went to that class thinking, I'm going to get it, right? So this case here, it says shipping is going to subscribe to the order, so is billing, just like we talked about. And shipping is also going to subscribe to billing and say, I want to wait until order's billed. So in shipping, it turns out, right, the order approved event comes out from the sales system. Order billed comes out, and then I ship. Just apologize. The demo is the other way around. It's waiting for it to ship and then it bills. Okay, in this model, you would need a saga, right, to coordinate those two events arriving out of order. And I'd have to wait for the other one. The shipping gets scheduled, and then we're done. Okay, let's skip these. These are a little bit annoying, but maybe I can explain it. So what happens when the bus gets one of these messages and you tell it you want to do a saga, you say, I'd like to start a saga based on the arrival of this kind of a message. Okay, or two messages. Right? So if I'm out there in billing, I'd say, I'm just subscribing, and when I get billing, I will wait. I will start my saga on order approved. Right? And you will go ahead and create a row in a database, all for you without you knowing it. If you're using SQL, it'll do it using Hibernate, and he'll create an object to represent the saga, and he'll serialize it off, waiting for the next handler to fire. Hey, I shipped, and it'll yank it out of persistence and complete the flow, right, and do the very last thing. It's a tough thing to explain, but it's actually not that hard to see. Should I just show you how it works?
Basically what it's doing is it's storing the one message, waiting for its companion message, and then it triggers the event.
Right, yeah, so we used to call it kind of a latching, you know, if you were an electrical engineer or something like that, you'd call it a latching, relay. I need two things to happen, and then once both happen, I'm interlocked, you know what I mean? It's kind of like that.
Oh, you could have 70 different messages in progress.
Yeah, so what you do though is, to do that kind of stuff in normal code, right, we could all do it. We could take that handler and we could gin up a row in a table and say, well, hey, thanks for the order, but I'm gonna sit on you until I know you've shipped. And then when that shipping message came in, I'd do a query, pull it out and say, oh crap, I guess I got your order. Now you've shipped, I'll mark you as shipped. I'll do whatever I'm supposed to do to ship you. And then I'm gonna delete the row, right?
So it triggers that way.
Yeah, it's just built that way. Okay, so let's just jack one up here. I'm rushing a little bit, guys, I apologize, but I want to be cognizant of the time here. Now, once again, you can go out to the Unservice bus site and go to NuGet, and it comes with a lot of samples, better explained than I'm doing these, right? The simple ones are easy to understand in the evening. Some of these other guys take a little bit more soaking in, right? So let's look at this guy, right? So I've got sales, and sales in this case is just a simple endpoint, and all he does is publish order accepted events. Right, so this is the website. He's the fire and forget guy. He just says, I publish orders once they're approved, right? And that's it. Now I could have him subscribe to other things, like if he was interested in when billing and shipping were completed, he could send them a subscription and he'd be informed, right? He can't query him request response though, right? Or he can't go RPC. He'd have to subscribe, which he could sure do. Yeah. And so we got sales. So let's go look at shipping. Okay. Well, first let's look at billing. You wanted to bump that percentage up again here? I'm forgetting to do that. Where is billing at here? Okay. So billing comes up as an endpoint. He just has an order accepted handler. He says, hey, if I get an order accepted, I'm going to go ahead and publish an order build event, because I don't really have anything to do, but it's in that spot that you would make your call into billing and you would do your stuff there. But when you were done, you would just publish an event to parts unknown. Hey, I had an order and I just billed for it, if anybody cares. Right? If they cared, I'd have a subscription. Okay. So let's go down to shipping, because he cares. So shipping comes in, and he's got this thing going on where he has got a saga. Okay? And this guy is a lot like a normal handler in many ways. He just says, I handle messages of type schedule shipping response, because I'm going to invoke a shipping service that I'm going to expect a reply from. But I am started by messages of type order accepted, and I am started by messages of type order build. I don't care which, because I can't say which is going to arrive first. Right? If either one of these guys show up, go ahead and create me. Okay? Right, so here's the order accepted handler. The stuff that you get here is telling the Saga when a message comes in, how do I line him up with the instance of all the persisted ones I might have. In this case, he says the Saga's order ID better meet the object's order ID. Right, so this is correlation. Right? Not too bad. But here's the handlers then, right? I just got a bunch of them. Hey, if I get order accepted, data.order ID. So store the order ID in my Saga data. So usually with these, right, you always have to have a little context. Like in Windows workflow or something, you'd probably just have a bunch of, private variables you'd store stuff in, and they'd be serialized out to the database when it's stored. This is the same thing. I better know the ID, I better know the originator. Any of the stuff I want to keep between handlers, I better stick up in the Saga data class. Right, so you go back to the saga, and he just says, I handle the order accepted, I handle order billed, okay? Right. Try mark complete. So see up here where it says order ID equals, I store the order up in state. I publish order accepted received for order ID, try mark complete. If I go down to try mark complete, he's just going to go up and see if everybody's happy. In the saga data, did I already get the order? If so, I'm going to publish the event that says shipped, and I'm going to mark as complete. That's in the superclass, and it deletes the row. Right? So here I've persisted this whole thing to a database, and it'll survive. But let's just go run it once. Getting a little low on time here, guys. I apologize if it's a little bit confusing. Let's see if it makes sense when we see it run. So here's sales. Okay. Here's billing. And again now, right, we know these to be endpoints. I can put them on different machines, different servers. It does not care, right? They just happen to all be, and it's going to build up all its own queues again. Input a quantity, create an order. All right. Let's look at what he said first, right? Subscribing billing to the order accepted message. Subscribing shipping to the order accepted message. It's order 12. Okay. So billing got it, received it, and it published the billing event. We come and look at this guy. Scheduling shipment for order blah. So he picks up the phone and in turn publishes now request response to the scheduling service. When his reply comes back, the saga picks that up, says, okay, I guess you've shipped, and it says order shipped. Right? So I've done a whole business process now with no brokering and no tight coupling. Right? What if I take this ship scheduler service and I kill him off? Uh-oh. Can't take orders anymore, I guess. Right? In a traditional system, that would probably be true. Right? But here, it's not going to care. In fact, it'll be fine. Well, they're still firing. Why? Well, billing's still waiting. Shipping's out here. So I've confused myself a little bit here. Turns out that it actually is bill first, then ship in this model.
Yes.
Sorry guys, I'm a little rusty on my own code. But, so if we go out to, in this case, do you see a connection string anywhere? Right? In that saga there is one, but it's just for Raven. Okay, so anybody using Raven or any document database at all, like Couch or something like that? See, there's my sagas. If I look inside of them, they're pretty simple, right? There's that saga data. So this guy's sitting there waiting, right? He's saying, well, I accepted the order, I billed for it, but the bastard is not shipped yet. So he is not done. So how long will he stay there? For an eternity, right? What if I don't run Raven? Well, it ships with a SQL, you can just go change it and it'll use Hibernate to store it to SQL if you want to do that, right? So there's all these interfaces for this stuff. You can just go plug them out, right? But so now let's go out here and let's turn our shipping scheduler on. We probably won't get back to Raven in time to see them die off, but we can try. Now we should have looked in the queue explorer, right? Because we would have seen them sitting in the inbound queue of the ship scheduling service, right? Yeah, now they're gone. And,
Your saga just got deleted.
yeah, so let's see. Right now I got nothing. They're all gone. Right, into a SQL server, right, I go query it up. Does that make sense, guys? I apologize, I went through that really quick. But it's kind of like saying, hey, I've got this stateful thing now, so I can coordinate the arrival and departure of different events. Right? But it's key to say that it only handled events, right? I mean, that's kind of the thing, is you can use these for anything, let's be honest, right? I could take that saga and I could go make request response calls to services and broker it in a saga. It works, right? It prefers that you don't do that. The things it would say never to do would be in that saga, go do something really taxing, like a database query. Because those sagas, they're just listening on a queue like everything else, right? Message comes in and says, oh, I got a message of this type. I better find out who handles you. And it sees all these sagas in there. Which of you has an ID that matches this order ID? Yanks you out of the database, fires the handler, for that message, and then goes, jams them right back in the hole again. And it's doing that on every message coming into that queue, even responses to saga messages. So that guy is busy. If you did really long-running junk in there, it's not going to perform real well. Right? So it's really about all it should ever interact with is the message. Right? So we are at time and a little bit over, fellas. I think I got to everything but some of the challenges, right? But we kind of talked about those en route. You have to have MSMQ. Deploying them can be flexible, right? You can put them on all different things, but if you used to just jamming a website out that talks straight to a database and to web services, this takes a little bit more, right? And there's a ton of features that didn't cover, encryption, things like that, right? But if you go out to the website and pull it down, there's more demos and pretty good descriptions about what they do. All right, any other questions at the end here, guys?
So on the pub sub model, when you have publishers, like you said, there doesn't have to be a subscriber for it. Are those messages just configured with time type
They just won't go anywhere. So if you want to see a really fast publisher, just don't subscribe anybody to it. Because you think about it when so when we'll use these a lot of times, like we'll use them for integration. So I could write a console app that maybe pulled a table to try to glue some old system to the bus. Maybe it looks in there and says, are there any new rows that I can grab? And for each row, I'll publish a message. Well, if I don't have any subscribers, you watch those guys go, they'll just fly. Because all it does is it takes the message and it says, oh, I got a message of type blah. Let me go to my durable subscriber storage and see who's in the list to deal the cards to. And if it comes up with nobody, it just flies, right? You'll see it log, but it has nothing to do.
So the bus just would never actually send any messages out.
Yep, but if he has a whole bunch, you'll see him say, you'll see that guy go out. Or if you're on machine A and the subscribers are all around the network, if you shut off, if you take the network connectivity, you'd see 10 copies, right, in the outbound queue of MSMQ, all destined for different machines. Right?
And then a couple of on the ordering messages, you mentioned that this is doesn't handle ordering messages or doesn't want you to order messages.
It does not.
So how do you handle cases like in my past work? It's some of the common ones are like customer address updates. So those things I've used messaging for in the past, where
Right.
you want to make sure if they go on there and they update something and then they update something again a second later, you want to make sure those are ordered. How do you handle that in these types of systems?
That would be tough, right? If you only have a serial queue, right? But usually what you want to do is track it on that subscribing system, right? And say, hey, if this newly arriving one is actually older than the one I took, right? You make it the responsibility of the subscriber, is what we've had to do.
So you just have something in the message that you can make sure you can track.
And
when
some
it
other
came
things,
through.
you're right, exactly that. So other things I've done with this is, we had a lot of systems that, before we had sagas, we had pretty primitive means of orchestrating, right? Like let's say I go to a database and I grab a whole bunch of items in state A in a console app, get everybody in state B, do this thing to them, and then update them to state B, and then go to sleep. The next 10-minute run, it comes on and says, get everybody in state B, do this thing, and then update them to state C, right? Probably everybody's done that. Well, we replaced that and said, hey, get these console apps to do whatever it is they do, but if I need to monitor them and understand the process they're doing, I can wire them into the bus and just get them to publish events, right? Hey, I took order X and I did this. I took order X and I did that. And you can just wire up one subscriber out there that just listens to all these guys, right? And then he can go to a database and paint a picture of what's happening, right? It's a way to make these processes visible, right? So in your example, that's exactly what happens, because maybe console app took them from state B and that event arrived before the state A guy. Well, my database is gonna be wrong then, because it's gonna get them in the wrong order and say, well, he went to B and then back to A, even though I know that that's not possible. So you have to kind of write them a little bit situationally aware. Say if they come in, look at the date timestamp in the message, not at the arrival time. Assess the place you're jamming them into and enforce those kind of ordinal rules there. How many of you guys take orders through a website asynchronously? Anybody? Yeah, the businesses don't dig that so much. Right, they're always the ones that the customer must know if their bill got done. Amazon doesn't do it synchronously though, right? Ever screw up your CVV or something ordering junk on Amazon? They're happy as a lark, right? Hey, thank you for your order. Then you're on halfway to work and you get an email and it's, sorry, your card was declined. Right? Please sign in and fix the dang thing, right? Because the cost of that is less to them than keeping it all blocky and synchronous, right? I'm sorry, it looked like you had a question.
Oh, I just wanted to, if this work with Rabbit too?
With
Does
Rabbit,
it work
it
with
does.
Rabbit?
So 4.0 beta is out, okay? And I think Rabbit is one of these AQMP compliant messaging, right?
And Rabbit does have its own like pops up built in with
Yep,
it. So I was
it
wondering
does.
like how does this pops up work with maybe Rabbit's?
Yeah, it'll use it as the messaging infrastructure, right? So like right now in the whole thing you saw me do, you didn't really see MSMQ native ever, right? It was kind of transparent to us. And it turns out it'll also use SQL Server. So a queue becomes a table, right? So when I went out there and I said, hey, run this endpoint, and went out and created all those queues, I was using the SQL provider for messaging. It would just go create stupid tables for each of those, right? Retries, an endpoint, and then when I published, it would insert a row, right? And when I subscribe, it just basically switches out the queue for a table, and it does the same thing with Rabbit, right? I mean, you said you'd still use the exact same syntax. In fact, almost nothing in your code changes. The one thing that is critical does change, though. What's a feature of Rabbit that's not so great? It is not transactional. Okay? So there's this big debate, right? So if people hate that distributed transaction coordinator comes into play with MSMQ. And specifically when you're using it, I like the fact that if I take a message out of a SQL Server box, take a row out, right, insert one, and I'm doing it as a result to a message, right, I can roll the whole thing back. Well, if SQL's on some server in the back office, MSMQ is local, it needs the DTC to do that. It needs ports open for that to happen, right? And there are some performance implications, right? If you don't want it to leak, it has a cost. Well, we used to shut it off, right? But if you cluster, it's on. I think it has to be. But in the old days, when I first learned MSMQ, it was shocking to find out. As I recall it, you had to have SQL installed because it used a table under the covers, okay, back on Windows NT. Okay. And then they got rid of that and started using the file system. But it turns out even if you put SQL and MSMQ on the same box, it will still go to DTC. Because the MSMQ doesn't support what they call kind of an anonymous local transaction. Right? So people are really going after these other queues. Azure queues, right? In the cloud, if I wanted to publish a message up to an Azure queue, it'll do that too, right? Some guy wrote a package for that, but it's the same deal, right? So how do you get around that? Right? Take that credit card auth thing, right? How do I stop that credit card service from taking, authing twice? What was my solution when you asked me about ordinal publishing? Just make it that endpoint's problem. Make him recognize that he saw you before. That's called, there's a name for that, right? It's called idempotence. Right? It's an old name. A lot of people in the .NET world don't know it. I only learned it because of the time in Java. But make them idempotent, which you don't see a lot in the wild. Right? We connect up to FDR and a lot of different providers. They're usually not. Occasionally you'll get one when I say I want to create an account. You can set a rule to say don't ever take a duplicate social. Right? Freak out if I try to give you two. What idempotency really means, you don't want them to freak out. What do you want them to do? Give me the reply from the first time.
The same way.
Yeah. So if you're doing it yourself, you can do this, right? all these messages get a GUID too. It automatically gets a message ID. So what you'll see is people will say, I took this request for insert. I'll just store that GUID, and if I get another call, I'm going to look. If I already have you, I'm going to eat it and send the happy path reply. Right? That's how you hedge it if you're going, you know, if you want to get item potency. But you also, you know, store and forward is not guaranteed in some of those things, right? So there's been a lot of debate. And if you look at, like, ActiveMQ is another one that they wrote too. But ActiveMQ is like a old JMS, right? It's meant to be one big box. Right? So if all these distributed systems, that's great. But if all of our queues are on one central box, it kind of defeats that purpose of a distributed SOA. And so the people that are in love with that aspect of it get a little bit more uptight about that.
What's your favorite message system?
Well, you know, when I got to the current place I'm working at, you know, I'd done all that time in Java, and then I left for a while. I got out of IT for a bit, and I was at Citibank, actually. And Citibank used Tibco, and you know, if it exists, Citibank has it. You probably see the same about FDR for all I know. Big companies tend to, they buy a lot of stuff meant to make a lot of stuff go away, and it usually doesn't. And instead of being the replacement thing, it's just another thing, right? And so at Citi, they had MQ series, they had, yep, they have Tibco. We had a big presence at Tibco, but I wasn't a coder there, I was an architect. And so I got exposed to that a lot. And when I came to Meta, you know, they had, I'd say, a little bit more dated technology, no real bus, not doing any messaging, like most .NET shops. And I'm like, you know, when I lost my Java stuff and I had to write a bunch of services to do this kind of work, I thought, you know, there's no way I'm going to write something again, right? I showed you that list. Who wants to do that? Even if you use MSMQ, you still got to work with messaging, routing, and storage, and durability, and no thank you. So I started scouring the internet like a good coder, seeing, you know, what is out there. And there's like Rhino Bus, there's Mass Transit, there's N-Service Bus. But, you know, when I found N-Service Bus, it was the first one I could get to work pretty well. There's actually, I found a couple commercial ones too, right? I got a hold of a Chicago-based company that does another bus that's actually a commercial .NET one. It'll come to me as soon as I walk out the door. But anyway, I called them up to get a demo, right? Because I thought, you know, we need something like this here. Because I was a big believer in it. And they actually hit me onto BizTalk, which they also were a reseller for. So we did a big bake-off on BizTalk. And I like BizTalk, it was all right, but it's very GUI driven, and developers are like, I don't want to drop pictures all day, you know. And so there's that aspect of it. It's a huge investment too, right? I mean, if you want to get a real scalable BizTalk presence, I think it will cost in the, you know, tens of thousands of dollars, and a huge SQL instance to run behind it, right? But it had some nice things, but it's a tough resource skill set to get. Even experts might not be able to find a lot of BizTalk code, but maybe. But it was tough, right? I mean, that was one of those things, so we actually passed on that. Right? There's Neuron ESP is the other one. Right, so we did a little bit of a bake-off on it. And when I found this one, like I said, there's others, and I'm not here shilling for in-service bus. To me, it's more about the patterns and stuff like that. But, you know, it is pretty simple, right? It's just a bunch of DLLs, and if you're used to writing code, you know, you know, it's just a bunch of handlers. You know, once you kind of can understand how it pieces itself together at runtime and how these little nodes collaborate, it's not too bad. You can get training on it. I didn't get to the end of the slides, but there's, if you go to the website, they do have training, even in North America now. It's predominantly been a European thing when I first found it. But there's a place called Headspring out of Texas. A guy named Jimmy Bogard down there, that big NBC guy. I know Jimmy pretty well by now. But he does some training. The in-service bus guys themselves do. And but it's not that hard. So, you know, I'd say at present it's my favorite because my skills aren't that great at coding anymore. Heck, I can still do it.
Very software,
Right. Yeah. Well, and it kind of fits in that Eric Evans DDD kind of space too. Although I've been to both their classes, and if you ask them the same question, they'll disagree, right? You say, so you're new to here, right? No. But, so if you're into that kind of, because really, they would consider these service areas to be domains. So these events are domain events, right? Order approved, right? Order billed, order shipped, right? No broker, loosely coupled domain events. Right? Anybody else here using a different bus?
What do you think about WTF compare to?
Mm-hmm. Yeah.
Bus networks?
Yeah, WCF has durable messaging now too, right? You can wire that in there. I'm not a huge, I don't have a lot of experience on it, but that question comes up a lot. It does not support pub sub, although you can make it, there's also Azure service bus, right, coming down the line. But there are documents out there if you go to the Unservice bus site. I mean, like I said, would I look at those? Absolutely. I just agree with that fact, nothing simpler, right? If I said, hey, whip me up a WCF service that does that, and we had a bit of a race, it'd be tough to, you'd have to be really proficient at the WCF stuff to do it, in my opinion. Right, with this, it's pretty dang simple when it comes right down to it. So for me, bang for the buck kind of deal. When I came into it, it was totally free. That's only changed slightly. Like I said, it went from free to cheap compared to anything commercial. Anything else, guys? I appreciate you sticking around a little late, and I apologize for that. It's not that nice out anymore now. It's probably dark. That's the advantage.
I use Red Hat Merge, messaging real-time grid.
Oh,
The
okay.
messaging portion of that, that's also AMQP.
Okay. Yeah, I've never been on that. Like I said, the ones that I was on, that would have been in the 2000, 2002 era on Java. And so, like I said, I don't like to give Java a lot of credit for stuff, but they were doing a lot of these things first. It was sometimes tougher. Right? The IDEs and stuff could be real challenging and primitive. And they didn't support schema at the time, so we had DTDs, and that, that's on that glass shard eating plane. But once you start doing it this way, it's kind of like test-driven development. It can be a pain to get your mind around, but a lot of people, once they get to it, you can't pry it out of their cold dead hand, right? And that's the only way to get it back. And so you can get addicted to these kind of things. But you know what? Depending on your goals, it's not for everybody, right? If you're doing some slow-rolling Hello World app, absolutely not, right? It's really around, places like Amazon, real high velocity type things. Or just the separation aspect of it's kind of nice. Right. Yeah, the little I don't know how they do that. One of the things that's interesting is, right, in web technology, there's still no push to the client, right? So you do end up polling a little bit, right? If I wrote that website that threw that order over, another thing you see is the CQRS deal is very prevalent in the bus community.
There are JavaScript libraries that maintain and cache back to the server.
Yeah, and then what's the new one, like Sigma R? Right, so somebody will wire that back into that response queue. Now there can be some other weird challenges really around MSMQ in that required, right? Because I don't know about you guys, but if your machines are out in the DMZ, are they in the same domain as your internal machine? That's right, so it makes it hard for MSMQ to talk to each other when that's the case. Okay, so getting a message back to a web server, if you want that local queue, not good. So they usually
MSMQ has the web messaging portion. So
What's
that MSMQ has the web messaging portion, so it actually can receive through IIS.
so you wire it up that way. I've seen that. I've never done it. And so with this thing, it's all private queues too, right? You notice I didn't use public queues where MSMQ tries to take a larger role. They don't work well, right? Because it's built around that notion of local autonomy, right? This transactional intermediary that's lightweight and extremely highly available, mostly because he's local, right? So this notion of putting all your queues in a SQL cluster, right, doesn't quite feel right sometimes. What if I put a standard instance of SQL on my machine? Similar.
Well, Or at least SQL could be replicated or load
Yeah.
balanced or.
Right. A lot of places like our bank, if you have SQL, we got it in, you know, in droves, and it's heavy iron, you know, quad redundant and backed up and clustered and gigantic.
I just don't like MSMQ because their transactions actually only guarantee that it arrives in outbound queue. It doesn't guarantee that it arrives at the.
It can't,
Yeah.
because it's a distributed messaging platform, right? Well, so, but even if you're using ActiveMQ or something like that, it guarantees that the ActiveMQ machine will address it properly and stick it in the channel that you're supposed to peek. How do I know if you'll peek or not? I don't, right? So in a way, you know, there's no guarantees, right?
Oh yeah, there's
Once-
good things.
Once you go asynchronous, it's kind of a big commitment, though.
We just didn't load balance MSMQ with
Oh, yeah.
transactional messages because it's so disconnected that
That's-
it does basically the.
That's a great point. I mean, that's why they're driving a lot of these other messaging technologies into it, because MSMQ comes with pain. But, you know, the way we run it is on VMs, though, right? So if one VM is writing to MSMQ, that's really a file on the file system. But is it local? No, it's on like a SAN drive, right? So if that VM rolled over, what would I do to recover my messages? Start another one up and bind them to the same message store, right? The other thing you see people do that's really weird with VM is you can go in and, let's say I had a service that was doing these zip code lookups and it had an SLA that was really good and it needed to be fast. Could I monitor that SLA in this system? Absolutely I can, right? Because I see the message come in, and if I know when the reply went out, it's easy to calculate. If they bury all that junk in the header, right? So there's a pen that'll tell you that. Okay? It says, hey, you know, watch this service, and if it gets slow, right? One of the things I didn't show you is changing thread count is just a configuration. But if I go in and say I want this receiver to run on 8 threads, it'll just do it, right? The queue is transactional; they won't fight each other. As long as the downstream thing I'm calling is clean. If it's a bunch of SQL queries that are intertwined, they're not gonna take a multiple thread load very well. Right? But what they'll do is you could go out there and with something like SCOM, you could watch that pen and say, if SLA drops below blah, run a script that does what? Jacks up another VM, right? And you can put this thing called the distributor that comes with N-Service Bus out there that'll fan out messages, right? So if you did that request, it'll sit there and with no code, right? It's a configuration thing. It will take the request and it'll manage a legion of, you know, minions out here, and it'll deal them to them. And when they're ready, they'll signal back, and he does that. So it will just prop up another one of them in there, and then as the load subsides, the script runs that tears them all down. But you'd have to be in pretty rarefied air to meet that, right? I mean, we don't do that, right? We run the bus primarily in some newer products where we're brokering, or once a broker, we're orchestrating, you know, these multi-step creational type things that need to go right. Anything else, guys? Oh, that's a sign from above, saving all of you guys.
Read that.
All right. Yeah, now we can see you. All right, well, that concludes my presentation, guys.